This exercise is made up of two parts, and this is the first part. So before we begin writing our script, let's first prepare the files that we need for this exercise. In folder B, this contains all the collection of handwritings for letter B. And folder C contains all the handwritings for letter C. And same goes with letter X and letter Z. Test image folder contains scanned test papers that we will use for extracting the handwritings inside the boxes, and then we will identify each handwriting if it is letter B, Z, X, or C. Now that we have all the images in place, let's now start writing our script. Inside of our VS Code, let's locate the folder that we have created a while ago, and we can do that by going to the File menu, select Open Folder, and then on the desktop, let's find the exercise 2. Then click Select Folder. We can now see the folders that contains the handwritings for letter B, C, X, and Z. So the test folder is also here that contains the scanned test papers that we will be using as the input image. So next, we will create a file. This file will help us to create the classifier. So to start, let's right click and then select new file, and then we will name this file build classifiers. Okay, so let's import the necessary libraries. Let's start with the NumPy, then OpenCV. Then let's open the images that we need for this exercise, such as those handwritings of letter B, C, X, and Z. So we have to state here that the file is inside of the B folder and the file name is b.jpg. We'll do the same step for the rest of the letters. Letter C, X, and Z. Just to make sure that we are correctly writing everything, let's run this application. Oh, we forgot to turn this to /. So our file is doing fine. So the next is we will create a variable for the size of the character image. So we will use these variables to maintain a proportion size for all the characters that we are going to extract from our collection of handwritings for B, C, X, and Z. So we will name this variable resized image width and resized image height. Then we are going to create another set of variables that will contain the numeric value of our letters for B, C, X, and Z. And we will name our letter B char B. And the numeric value of letter B is 66. The same goes with character C. And the value of this is 67. Character X, value is 88. And char Z, the value is 90. Okay, so let's try running this again so that we can make sure everything is well. Okay, so there is no error. So let's continue. Then we have to turn these images into grayscale. So we have to create another variable that will contain the grayscaled image. So for image B, we'll name this img gray B. Okay, and then same thing with letter C, X, and Z. Okay, so let's give this a try again. Okay, so we have an error. So it says here, CV2 has no attribute color BG to gray. Or it should be BGR to gray. Okay, so let's try this again. So it goes well. Then let's continue. Then we have to get the threshold of each grayscaled image. So we will name this img thresh B. And then for the grayscale B, we have to set this to 150 and 255. So we will do this for the rest of the letters. And so let's run again the application just to make sure that we don't have any errors. Okay, so it goes well. I forgot the threshold is expecting for a tuple. So that is why we have to add here. Okay, so let's test this again. Okay, so it goes well. So after that, we will make a copy of each threshold. So we will name this img thresh copy b, and then we will copy the threshold of b. And then we will now find the contour of this threshold. So we will store these contours inside of these variables img contour b. And then for the hierarchy, let's just name this hb. And then we will call the cv2 dot find contours. And then what we are interested in is the outermost contour. So that is why we are going to state here cv2 dot that are external using the approximation as simple cv2 dot chain approx simple. So we will do this for other letters. And then we have to create a variable, a list variable that has a size of our constant at the top, this one. Okay, so let's create here. We will name this flattened images. Okay, so we have a list that contains 0 with the size of resized image width times resized image height. Then another list variable for our classification letters. We will use this variable to contain the character images that we can find inside of the collections of letters. And then this one will contain all the numeric values of the letters, such as the B, that is 66, and C, that is 67, and so on. And then next, we will iterate in each contour found in the contours. So for each contour in contours, we have to get the boundary of the contour. And we can do this by using the boundRect function of the CV2. So let's state here CV2, and then this will return four values. So we have to store these four values, and then we will create an image that will contain the extracted character from the collection of handwritings. And we will name this img roy b. And then the size of this will depend on the size of our threshold using the values of our int x. I'm sorry, this should be y, and this should be x. Then after that, we are going to resize this. So we will name this img resized, and then we will call the resize function of cv2, and then we will state here the image that we will resize, and then the value of the new size. Then we will use these values for our new size. All right, that's it. Since we know that the image that we are dealing with right now are all letter B, this means that the letter that will classify this has a numeric value of 66 because that is letter B. So that is why in our int classification, we will append the car B. And then after that, we have to turn our resized image into one-dimensional array so that we can write it in a file. So we have to do that by stating here flatten image. So we will create another variable After turning our image into one-dimensional, then we have to add it on our list variable. So if you can still remember, that is the flattened image. We will state here np.append flattened image, and then flatten img. And let's state here 0. So the 0 here refers to the axis. And we will just supply 0 because we don't have any intention of filling out a particular axis in our array. So that's it for letter B. So let's try this out. CV is not defined. Okay, so I guess we have to turn this to CV2. Okay, so it goes well. So we have already created the classifier for letter B. Then the next is we are going to proceed now to letter C. So the step for letter C is the same as the step that we did for letter B. So it means that we are just going to copy and paste everything here until we reach letter Z. So let's just copy and paste this. And then another one. And then for the last letter, okay, so we are through with all the letters. And then we will turn our classification letters into an array of floats. And we can do that by creating another variable. We will state here FLT classifications np.array in classifications np.floats. So at this point, we have now the classification letters turned into an array of float. And then we have to turn this into a one-dimensional array so that we can save it into a file. So we will call this final classification equals to FLT classifications. And then we have to reshape this. Then we will write here complete. And then let's save our file. Let's name this classifications.txt. Then let's feed here the final classifications. And then for our character images, let's save this as flat car images.txt. And then we will write here the flattened image. Okay, so there you go. So let's save this and then let's try running this application. So we have an error. It says here line 54, resize in function cv.resize. So let's go to the line 54. Okay, so we forgot to rename this into C. Okay, so let's run this again. Okay, line 73, it says here, pertains to the resize function also. So we forgot to rename this to Z. And let's test this again. So we have successfully created the classifiers that contains the following files, classification, and the flat images. Okay, so that's all for this video, and then continue watching the part 2. On part 2, I'm going to show you how to train this classification. That's all, and see you in the next video.